Let's go on to the second special right triangle, and that's the 30, 60, 90 triangle. So there's these two that are very special that have these short little quick shortcuts that you can use. So the first one was the 20 or 45, 45, 90. This one's 30, 60, 90. So again, I have some Pythagorean theorem problems. Let's try these. I have two sides labeled out. Notice they're all 30, 60, 90, and we're going to practice these to see if we can come up with what the pattern is. It will help us do the shortcut. So a squared plus b squared equals c squared. A squared is 5, b squared we don't know, but c squared is 10. So I get 25 plus b squared equals 100. I'm going to subtract 25. B squared equals 75, and then I take the square root. B is equal to the square root of 75. Now I can break that into the square root of 25 and the square root of 3. Square root of 25 is 5. So my answer here is 5 times the square root of 3. Alright, let's try the next one. A squared plus b squared equals c squared. We'll draw our little line there to keep them all separate. This is going to be 3 squared plus b squared, again I don't know, equals 6 squared. It's going to be 9 plus b squared equals 6 squared. Oops, not 6 squared, 36, because we're squaring it. 9 plus b squared equals 36. Subtract 9 on both sides. B squared comes down and I get 27. Take the square root of both sides. So b equals the square root of 27. Now I can break that into the square root of 9 times the square root of 3. Square root of 9 is 3. Square root of 3 is 3. So this here is 3 square roots of 3. And then my last one. I have a squared plus b squared equals c squared, Pythagorean theorem, because they're all right triangles. Now, again, it doesn't matter if I call this a or this b, that doesn't matter, but I've been calling this a consistently, so I'm going to do that still. Equals 20 squared. 10 squared is 100 plus b squared equals 400. Subtract 100. B squared equals 300. I'm going to take the square root then of both sides. That cancels out. B is equal to the square root of 300, which can break into the square root of 100 and the square root of 3, which then simplifies to give me 10 times the square root of 3. So I'd like you right now to focus, didn't mean to do that. Focus on just our right triangle side lengths. This stuff right here. Okay, so in the first one, they're all 30, 60, 90. The first one, our little leg is 5, our hypotenuse is double that 10, and our big leg is 5 square roots of 3. Second one, our little leg is 3, our hypotenuse is double that 6, our big one is 3 square roots of 3. Third one, our little one is 10, our hypotenuse is 20, our big one is 10 square roots of 3. Think of this like you're playing a video game and you just found a trick, and this is going to help you, get to wherever you're trying to get to a lot faster. It's going to help you achieve what you want, and that's really what's going on here. If we know the little leg, or if we know one of them, we can always figure out all the other ones. So in this case, if I know the little leg's 5, I know for sure the other leg is going to share that same number. Both my legs are going to have the same number in them, but to differentiate between two of them, because one's big, one's little, the big one also is the square root of 3. And you can remember it's 3 because there's a 30. The 45, 45, 90 was square root of 2, but that's because we had two of the same sides. Then our hypotenuse is just double whatever the number was. So the formula, the pattern here is this is going to be x. This is going to be x times the square root of 3, and our hypotenuse is 2x. Okay? So again, the legs are the same number, just the big one has the square root of 3 with it. The hypotenuse is double. So example 2 says find the length x of the hypotenuse and the length y of the longer leg of the triangle. So we have to find x and we have to find y. So they give us the little leg. The hypotenuse is double the little leg, so x is going to be 8. And then we have to find y. But the other leg, the two legs have the same size. Oh, so this one's also going to be 4, but if I just put 4, obviously that's not right because that one's longer, so I have to remember to add on the extra thing, 4 square roots of 3. So this is 4 square roots of 3, this is 8, 4 square roots of 3, 8. That's it. Let's try example 1 you try. Find the unknown length, write your answer in simplest form. So here they're giving me the hypotenuse. I know my little leg is half of that, so that's 4. And my long side, just like we saw above actually, is going to be 4 square roots of 3. And that's it. This one, the little leg is 3. The hypotenuse is double it. My long leg is going to be 3 square roots of 3. And in letter C, I have my long leg as 4 square roots of 3. My little one is going to be the same number, just without the square root of 3, and my hypotenuse is double. It's going to be 8. So we actually have 3 of the same one right there. But as long as you keep that concept in mind, that the little leg and the big leg share the same number. So if we have a triangle and it's 30, 60, 90, if this is 5, this is also 5. But because they're different sizes, the big one is the one that gets the square root of 3, because it's extra to it. And the hypotenuse is the biggest one of all, so that's why it's double. It's 10. Okay, so that's kind of the way that this works. We'll be practicing a lot in class, but that's it for how to do these. And then watch the next lesson. I'm going to go over the theory of how this one works also. Okay, good job, guys.